Hello again, this is Dr. Jim with engineering clip, video clip number 6. Here you can see the KissOS 0.1a.spin. This is the shell that I talked about in a previous video clip that is actually running. Now, the very first thing we have to have is an operating system which will manage all of the memory and I/O resources that we have in this system. We can't just have it be helter-skelter, and so an operating system is necessary as the bedrock to build upon to be able to implement this machine intelligence. And so I'm going to scroll down here. And to give you an idea, the very first thing that you have to do to be able to do machine intelligence processing is to turn the information, the data, turn it into, instead of absolute data, into something abstract where it is not absolute. And here I have a little algorithm. It starts from right here as the initialization, and then this repeat loop, and then drops out. And this right here basically does a compression and abstracting of what you type in on the keyboard. That will, of course, be replaced by the voice inputs. They will come in at exactly this same point, and they will be compressed with this same algorithm so that you are talking to the operating system. And the keyboard will become less and less necessary until it's completely eliminated. And the beginning of our process of vocal interaction with the machine will be for it to understand two words, yes and no. And regardless of what language that's in, the two words, yes and no. And from that, we can build that as a foundation. We can build then a hierarchical logic scheme that allows us to verbally issue commands where we normally would have done that through keyboard, typing something in and then hit the enter key. And so as you can see, what we're doing here, for instance, is compressing a string of characters in characters, in other words, any number of characters, and we compress it down to one long, that is 8 hex digits or 32 bits. And that 32 bits then, if you type in, let's say, something along the line of a, let's say, get address, it would go right here to this routine, and it would be compressed down to this 39 Baker Easy Fox. That is actually that whole string that says GET space ADDRESS enter, and it will automatically come here. Notice this is a case statement, and it's using the CRC, or the compression, the results of the compression, and it will give us then the main RAM address of the cog ID. That is the variable that we call cog ID. And so you can see then how we can easily interface in a very minimal amount of memory, extremely small amount of memory. We can interface a very wordy command structure and compress it down to something that can actually be handled within our 32K limits of main memory. And so, yes, here I have a system that I use to develop the the operating system code on. This is the thumb drive, as you can see, and there's a cable going over here to our proto board. And then this is a 2 meg memory card that we designed, and you can stack these. Here's more of them, for instance. And then they interface through these 2 cables, and also other things can interface through those 2 cables. And then this connector over here that would normally be the mouse connector will actually be the connector from board, proto board to proto board to proto board. That will be a bidirectional serial interface of 3 megabits per second. So we will use that to communicate between propeller boards. And I'm going to have to sign off again for my 3-minute clip for this session, and we'll pick up where we left off next time.